For a few minutes, in the middle of the day, the sky goes dark. The birds stop singing, the air turns cold, and where the sun should be, there's now a black hole ringed with fire. For thousands of years, this terrified entire civilizations. People thought the world was ending. And honestly, you can see why. But what's really happening up there is even stranger than any myth. And by the end of this video, you'll understand it completely. So let's start with a simple question. What actually is a solar eclipse? Well, you already know the two main characters, the sun and the moon. And here's the thing we learned last time. The moon is constantly orbiting the Earth. Usually it passes above or below the sun in our sky. We don't notice a thing. But every so often, the timing is perfect. The moon slides directly between the Earth and the sun. And for a brief moment, it blocks the sun completely. That's it. That's a solar eclipse. The moon casting its shadow onto the Earth. But wait, this is where it gets almost unbelievable. Because for this to work so perfectly, something has to be true. And it's one of the strangest coincidences in the entire universe. Think about it. The sun is gigantic. The moon is tiny. The sun is about 400 times wider than the moon. So how could something so small ever cover something so massive? Here's the trick. The sun is also about 400 times farther away. Those two numbers cancel out almost perfectly. So from right here on Earth, the sun and the moon look exactly the same size in the sky. Let that sink in. There's no reason it had to be this way. If the moon were a little smaller or a little farther, we'd never see a total eclipse at all. We just happen to live on the one planet at the one time where the numbers line up. And that perfect match is what creates the most spectacular sight in the sky. So what does a total solar eclipse actually feel like? Because trust me, watching it happen is nothing like hearing about it. Let's walk through it, moment by moment. It begins quietly. The sun looks completely normal. Then, if you had special glasses on, you'd notice something. A tiny bite missing from the edge of the sun. The moon has started to move across it. But down on the ground, nothing feels different yet. The day looks the same, then slowly, over the next hour, that bite grows. The moon creeps further and further across the sun. And this is where it gets eerie. The light around you starts to change. It doesn't get darker exactly. It gets weird. Colors look strange. Shadows turn razor sharp. The world takes on a silvery, unreal quality. Animals start to get confused. Birds head back to their nests, thinking night is coming early. And then, in the final seconds before totality, everything accelerates. The temperature drops fast. A wall of shadow, the moon's shadow, comes racing towards you across the landscape at over 1,000 miles an hour. And then it hits. The last sliver of sunlight vanishes. And suddenly, you can look up with your bare eyes. This is totality, and it is breathtaking. Where the sun used to be, there's now a perfect black disk, surrounded by a shimmering halo of white light streaming out into space. That halo has a name. It's the corona, the sun's outer atmosphere. It's always there, but is normally drowned out by the sun's blinding glare. Only during totality, with the sun perfectly covered, can we finally see it. Stars come out, planets appear, in the middle of the day. And here's the part that gets people every time. It doesn't last. Totality lasts only a couple of minutes, sometimes just seconds. Then, on the other side, A brilliant point of light bursts out from behind the moon, like a diamond on a ring. And just like that, the light floods back. The corona fades, the sun returns, and everyone who saw it is left completely changed. People travel across the entire planet for just 2 minutes of this. And once you've understood what you're really looking at, you'll know exactly why. So, if the moon orbits the Earth every single month, why don't we get an eclipse every month? It's a brilliant question. And the answer reveals something most people never realize. You'd think that once a month, the moon would slide right between us and the sun, and boom, eclipse. But it almost never lines up. And here's why. The moon's orbit is tilted just slightly by about 5 degrees. It doesn't circle the Earth on the same flat level as the sun. So most months, when the moon passes between us and the sun, it's actually a little too high or a little too low. Its shadow misses the Earth completely, shooting off into empty space. It's only on those rare occasions when everything lines up just right that the shadow lands on us. That's why total eclipses feel so special. They're not just beautiful, they're rare. But not all eclipses look the same. And this next part surprises a lot of people. Remember how the moon's distance from us can change? Its orbit isn't a perfect circle. Sometimes the moon is a bit closer, sometimes a bit farther. And when an eclipse happens while the moon is farther away, it looks slightly too small to cover the sun completely. So instead of total darkness, you get a blazing ring of fire in the sky, a bright circle of sunlight around a black center. That's called an annular eclipse. Same event, different distance, completely different show. Now, here's where it all connects. Everything we've talked about is a solar eclipse, the moon's shadow falling on Earth. But there's another kind. Flip the whole thing around. What if the Earth gets between the sun and the moon? Then it's the Earth casting its shadow onto the moon. That's a lunar eclipse, and it's completely different to watch. It's safe to look at, it lasts for hours, and the moon doesn't just go dark. It turns a deep, haunting red. People call it a blood moon. But why red? Why not just black? Well, even though the Earth blocks the direct sunlight, our atmosphere bends a little light around the edges. And that light, filtered through every sunrise and every sunset on Earth at once, falls softly onto the moon. You're literally watching the glow of all the world's sunsets painted across the moon's surface. And that's a perfect example of what makes all of this so worth understanding. So now you know what's really happening when the sky goes dark. But I saved the most incredible part for last. Because that perfect eclipse, the one people cross the planet to see, won't last forever. Remember the moon is slowly drifting away from us? A few centimeters every single year. And that means very slowly, it's shrinking in our sky. Right now, the timing is perfect. The moon is just big enough to cover the sun completely, but it won't always be. In the far future, hundreds of millions of years from now, the moon will be too far away to ever fully cover the sun. Total eclipses will simply stop happening. They'll vanish from the sky forever, which means something quietly astonishing. We are living in the exact window of time when total solar eclipses are possible. Not too early, not too late. Right now, if you ever get the chance to stand under one, take it. You're witnessing something that won't be here for the whole life of our planet. So let's bring it all together. A solar eclipse is the moon's shadow falling on Earth. made possible by one of the luckiest coincidences in the universe. The corona, the ring of fire, the blood moon, they're not omens or magic. They're just light and shadow and geometry. But knowing that doesn't make them less beautiful. It makes them more. Because now when you look up, you don't just see it, you understand it. So here's my question for you. Would you travel across the world to see 2 minutes of totality? Tell me in the comments. I read every single one. And if this gave you that spark of wonder, subscribe and stick around because next time we're going somewhere even stranger. Until then, keep looking up.